Okay, let's do. So this is the course of physics of mechanics and heat. This is the 3 credit semester in this semester, yeah, for the short semester. Uh, so our schedule in Monday and Wednesday at 10 a.m. and in this room, yeah, in S204, we'll do the offline class or direct class, and maybe sometimes we will do the online class if I can attend in this class, yeah. But actually, in general or in default, we will do in offline class. Yeah. And also we have another media here, like a mass, and then YouTube. Maybe I can share or I can record the meeting, and I will share the record of the meeting to the YouTube. Yeah. And maybe we'll add the WhatsApp group after this. Yeah. Okay. My name is Ahmad Prayogi. I am a lecturer of physics in Faculty of Engineering UI. And my email is this one, yeah, prayogi@ui.ac.id. Okay. Okay. So for the evaluation of this course, yeah, there are several evaluations like assignments, quiz, midterm test, and final test. Yeah. For the assignments, the percentage is 20%. Yeah. Assignments, quiz, 20%, and midterm test will be 30%, and valid final test also 30%. And then in general, for the physics, mechanics, and heat, uh, we will use several kind of physics book, like Fundamental of Physics, Halliday Resnick, then edition, Physics for Scientists and Engineers, Survey Jiwet, and Physics for Scientists and Engineers by Jan Collie. Yeah. So you can find the book in the library or in other source. Okay. Any question for this introduction? Yeah. Okay. No. Yeah. Okay. For the materials or learning issues and topics, we will divide to actually 14 meetings, yeah. 16 meetings with midterm and final test. So we will divide to 2 parts. Yeah. The first part is before midterm, yeah. And then the second part after the midterm. Yeah. So for the first, we will study about physics quantities, unit and vectors. Yeah. Also in the second meetings, yeah, we'll study about kinematics. This one is motion along straight line, motion in 2 and 3 dimensions. Yeah, this one is the reference. Yeah. You can find the chapter 1 and chapter 3 in this one book. SRW is, it means that Halliday, Resnick, and Walker. Yeah, in this one book. This is the uh in the this one, yeah, Halliday, Resnick, chapter 1, chapter 3. Yeah, for the first topics. Yeah, and also for the second, chapter 2 and chapter 4. Yeah. Okay. In the first week, actually we will have 2 meetings. Yeah. Today for the introduction, we will learn about vector and units and quantities. And then also in the second meeting, yeah, we'll study about kinematics. This one is motion in 1 and 2 or 3 dimensions. Yeah. And the third meeting, yeah, there is dynamics. This one is Newton's laws of motion. Yeah. And the application of Newton's laws. Yeah. Actually, in the general semester, we will do 4 times quiz. Yeah. There are independent quiz and joint quiz. Joint quiz is means quiz bersama with the other class. Yeah. But I think for the short semester here, I think only 2 quiz is enough. Yeah. I will combine the independent quiz and joint quiz. Yeah, become 1 quiz before the midterm test, and then after the midterm test, we also do 1 quiz. So only there are 2 quiz in this short semester because the time is very limited, I think. Yeah. So maybe I will combine. Yeah, the first quiz, maybe the independent quiz one, and then the joint quiz one. We will do in the There will be the 5 meetings after. Okay, and then in the and the 4 meeting, we'll study about work and kinetic energy. Work and kinetic energy, and then potential energy and conservative of energy. Conservation of energy. You can find in chapter 7 of chapter 8 in the Halliday Resnick Walker books. And in the 8 topics, it means in the 5 meeting, we'll study about momentum, impulse, and collisions. And then in the 6th meeting, the rotation of rigid bodies, dynamics of rotational motion. And the 7th meeting is simple harmonic motion. Before we will do the midterm exam. Actually, in this schedule is not update, but in general, the time is similar. In the 7th meeting, and then we will do the midterm test. And then after the midterm test, this one is focus on kinematics and dynamics and energy, and also for simple harmonic motion. After that, we will study about waves, mechanical waves, and sound, gravitation, statics and elasticity, fluid mechanics, and also maybe for the joint quiz and independent quiz, we will combine to only one quiz. We'll combine the static and change of matter or heat transfer here will be one quiz. Fluid mechanics, and then the 11th topic is temperature, heat, and the first law of thermodynamics. And then the 12th meeting is kinetic theory of ideal gas, and the kinetic theory of gas. And then for the 13th meeting, it will be heat engine, heat pump, entropy, and the second law of thermodynamics. And the 14th meeting or the 15th meeting, it will be the final term of preparation. Okay, this one is topic. So the topic of physics and mechanics and heat is cover fundamental of physics, especially in physics, mechanics, and heat. It's contain temperature, thermodynamics, and kinetic theory of gas. Okay. Okay. Any question for this topic? Yeah. Yes. Yeah. Uh, this this file. Yeah. Maybe I will share in mass. Mass. Okay. Yeah. Okay. And then this is the subject learning outcome. So this one is the output of this course. After the completing this course, students are expected to be able to apply the fundamental concept of mechanics and thermodynamics to understand natural phenomena and human engineering, including their applications. That's why physics is the fundamental or foundation of engineering. It becomes important part in engineering faculties or for the engineering student. And then divide to subs learning outcomes. Subject sub learning outcomes. The first one is to able to analyze and solve problems related to the motion of rigid bodies or particles without considering the force causing them by applying principles of calculus, vectors and equations in motion in 1 and 2 dimensions, both analytically and graphically. This one is the first sub learning outcomes. Okay. I think the important tools here is calculus, the principle of calculus, vectors, and equation of motion. And then the second is able to analyze and solve problems involving motion and equilibrium in rigid bodies and ideal fluids by applying vector principles and Newton's law of motion. Yeah. Okay, in the second sub-learning outcomes, the key point is equilibrium in rigid bodies. Yeah. And ideal fluids by applying vector principles and Newton's law. Yeah. Because Newton's law is the basic for the energy and for the fluid mechanics also. And then the third sub-learning outcomes, able to analyze and solve problems related to collisions and change in velocity in rigid bodies and ideal fluids due to conservative and non-conservative force by applying principles of calculus, vectors, conservation of laws, energy, and momentum. Yeah. So this one focus on energy, momentum, and conservation of energy and momentum. Yeah. By using calculus and vectors. So calculus and vectors will be the language, yeah, the language of solving the problems, okay, or the tools to how to solve the problems. And then in the fourth sub-learning outcome, yeah, is to be able analyze and solve problems involving periodic motion, mechanical waves, and sound by applying principle of calculus, vectors, Newton's law of motion, and the conservation of mechanical energy. Yeah, this one is periodic motion. Periodic motion, it means oscillation, yeah, vibration, and also for mechanical waves. Yeah, we need to understand about the equation of motion, of vibration and oscillation. Yeah, also for wave, yeah, especially in a mechanical wave. And then the fifth subtopic is able to analyze and solve problems related to change in temperature, phase transitions, heat transfer, change in velocity, yeah, and pressure in solids. Yeah. Solids, liquids, and gas, as well as pumps and heat engines, by applying principle of calculus, vectors, conservation laws of momentums, energy conservation, thermodynamics, and statistics. Yeah. Okay, in the five subject, it is about thermodynamics, heat transfer, and kinetic theory of gas. Yeah. Okay, this one for assessment or evaluation, the percentage kinematics, dynamics, and statics, and then energy and momentum, periodic motion, wave mechanics, sound. Yeah, actually every chapter will be there are portion for assignment, yeah, quiz, midterm or final exam. Yeah. Okay, this one is sub materials of sub learning outcomes. Yeah. Okay, this one is also a holistic assessment rubric. Yeah, the criteria of the assessment. Yeah, criteria of the assessment. You can get the A if you get excellent understanding and application. Yeah, it means that the students demonstrate a very strong understanding of how to solve problems and can apply concept exceptionally well. Yeah. Minor errors may occur but do not indicate a lack of understanding of fundamental concept. The use of appropriate analytical methods and techniques along with true and detailed solution reflect a high level of understanding. And then B or A minus, it will be good understanding with minor errors. Yeah. B is moderate understanding with some errors. C plus or B minus, this is the basic understanding with need for guidance. Yeah. And C is very limited understanding with misunderstanding. Yeah. And D or E, it will be inadequate understanding or lack of understanding. Yeah. Yeah, actually that's all for the assessment, yeah, criteria. And make sure that we have portion before, yeah. Assignment, quiz, midterm, and final test. Yeah. Okay. Okay, any question for the introduction and general information? Okay. Okay, if no, maybe yes, I have opened the mask. Yeah, maybe I will update later. Can share the slides or lecture notes in this platform, yeah, from IMAS. Yeah, okay. So still empty, yeah. I still not put everything here. Okay, I think for the chapter 1 here, we will review again about measurement, yeah, measuring things including length, mass, and another basic physics quantities. Yeah. Okay, in physics we will divide base quantities. Yeah, there are so many physical quantities that is the problem to organize them. Yeah. So for the base quantities, actually we will have this one. Yeah, length, time, and then mass. Yeah. Okay. Okay. And then this one is the international system of units. Yeah. The international system of units. Usually we say SI. Yeah. International standard. For example, in meters. Yeah. Meter is for quantity of length. Yeah. And then second is for time, and then kilogram is for mass. Okay. So this one is the unit symbol. Mass. We can use M is the symbol of mass, and then time. Yeah. Oh, I sorry, meter. Yeah, for this one is meter. This one is the symbol of length. Yeah, the unit name of length. And then mass is in kilograms. Okay, kilograms is for the mass. And then also for the SI units, we need to understand about the prefix here. Yeah, this one is several important prefix like centi, milli, micro, nano, pico. Yeah. Okay, for example, for centi here it means that 10 minus 2. Yeah. 10 power minus 2, and then milli 10 minus 3, yeah, micro, nano, pico, and the others. And also for kilo, mega, giga, tera, peta, exa, yeah, zeta, and iota. So this one is the prefix for SI units. Okay. Okay. For example, if we have the length or the size, yeah, of particles in nanometers, it means that 10 power minus 9. Yeah. 10 power minus 9 meters. Yeah. It's one in nanometers. So it means that 1 divided to 1 billion. Yeah. 1 billion is 10 power 9. Yeah. Okay, this one is several kinds of units. For example, watt, yeah, or we can say, or we can write is W, capital W here. It means that power, yeah, power. Power is energy divided to time, yeah. Power is energy divided to time, and then we can derive what is energy. Yeah. Okay, for example, if you can use watt here, yeah, it means that from 1 kilograms meter square divided to second power 3, yeah, or second cubic. Okay. And then also for 10 power 9 watts, yeah, it means that gigawatts. Gigawatts is GW. For example, this one is 1.27. Yeah, this is for gigawatts. Yeah. Gigawatts is 10 power 9. Yeah. So you need to understand and maybe remember or memorizing, yeah, several kinds of important prefix here. Usually for the capital, for the bulk, yeah, giga, mega, kilo, yeah, here, centi, milli, micro, nano, and the others. Okay, and also for the symbol, yeah, also for the symbol. Okay, and then changing units. Changing units is convert. Yeah, we need to conversion factor. For example, for time. Yeah, if we use in minutes, for example, we can use another units. For example, in second or in hour. Yeah, 1 minute is actually same with 60 seconds. Yeah, and if we can convert from 1 minute, yeah, this one is convert from minutes to second and reverse of this. Yeah. Okay, for example, 2 minutes, it means that 2 minutes times 60, yeah, because 1 minute is 60 seconds. Yeah. Okay, this one is basic concept of units. Yeah, we need to know the international standard of units and then the prefix of units. And then this one is several kinds of basic quantities. Yeah, quantities. Okay, for the first one is length. Yeah, this is the definition of 1 meter. Yeah, 1 meter. What is the definition of 1 meter? The meter is the length of path traveled by light in a vacuum during a time interval of 1 divided to around 3 times 10 power 8, yeah, meter per second. It's 1 second. So we'll get the C. C is the velocity of light. Yeah. The value is around 3 times 10 power 8 meter per second, or 299 million 792,458. Yeah. This one is the velocity of light. Yes. This is C. So 1 meter is defined to time, the path of the light and the vacuum during time in the form like this. Because in physics, you know that distance, distance is velocity times the time. Okay. It's for x p times with t. So this one is light velocity and time. So 1 meter, its definition is velocity. Velocity is here, c times 1 per second. So it will become 1, right? This one is the definition of 1 meter. Okay, this one is some approximate lengths. Yeah. Some approximate lengths, yeah, distance to first galaxies form, like in meters. Distance of the Andromeda galaxy, distance to nearby Proxima Centauri. Yeah. And then the other one is distance of Pluto, distance of Earth, height of Mount Everest, thickness of the space, yeah. The length of typical virus, radius of hydrogen atoms, and radius of protons. Yeah. So the radius of atoms, for example, yeah. This one is around hydrogen 5 times 10 minus 11. Do you know the hydrogen atom, right? The hydrogen atom is consists of 1 proton and 1 electron. Okay, this is the schematic of hydrogen atom. Okay, so for the radius of hydrogen atom here, R, this is the value is around 5 times 10 minus 11 meters. Actually, it's around 0.53. 0.53 angstrom. So angstrom is 10 minus 10, yeah, meter. So this one is 0.53 times 10 minus 10. This one is radius of hydrogen, for example. The radius of hydrogen atom is, we know in physics, Bohr radius. Yeah. This one is Bohr radius. So because Bohr is the scientist that proposed, yeah, the radius of atom here. Okay. Another one is the typical of virus. Yeah. Typical of virus is around 10 nanometers, right? 10 nanometers. Because this one is 1 times 10 minus 8. Yeah. 1 times 10 minus 8. Yeah. Maybe like coronavirus or another virus, yeah. The size is around nano, okay. 0.1 or 10 nano, 10 nano, okay. Okay, the second quantity is time. Yeah. You can see what is the definition of time. The definition of time, this one, yeah. 1 second. 1 second is the time taken by 9 million, yeah, oscillation of the light of a specific wavelength emitted by cesium 133 atom. Yeah. So this one is the definition of time. The oscillations of the light, yeah, of a specific wavelength emitted by cesium atom. Okay. Okay, the definition of meters and then second, yeah, this is from international standard, yeah. From international standard after several years, yeah. And then the scientists get the definition of meters and then second. Yeah. You can read the history, yeah, how they can make the definition of meters and second. Okay. And then mass, the standard of kilograms. Yeah, standard of kilograms. some approximation of mass. Yeah, this one is some approximation. Okay, before we have some value of time. Yeah, you see before. Okay, this one. Yeah, some approximate of time intervals. Yeah, lifetime of proton predicted by 3 times 10 power 40 seconds. Yeah. Age of the universe, age of the pyramid of Cheops. Yeah. And then length of day, time between human heartbeats, lifetime of the muon. Yeah, muon is kind of particles in atoms. Yeah, and then the Planck time. Yeah, Planck time is 1 times 10 minus 43. Yeah. Time interval in second. Okay. Okay, and then for mass, yeah, some approximation of mass uh, from electron. Electron is 10 times 10 minus 31 kilograms, and then proton 2 times 10 minus 27. Okay, this one is the mass of proton and mass of electron. Okay. Mass of proton is 2 times 10 minus 27. Yeah, and electron is 9 times 10 minus 31. Okay. So the mass of proton actually around 2000, 2000 of mass of electron. And then another quantity of mass here, negative quantity of mass. This is the atomic mass units. Yeah, atomic mass units in U. Yeah. So 1 U is 1.6 times 10 minus 27 kilograms. This one is the mass of 12 atomic mass, carbon 12, carbon 12. Yeah. So this one is atomic mass units. Yeah. And then density of mass is mass divided to volume. Yeah. Rho, it means that mass divides to volume. Okay, after we have review about quantities and measurement, so we'll do the uh, review about vectors. Yeah. So vector and their components. Vector definitely will be the quantities that there is the direction. Yeah. We can divide vector and scalars here. Scalars is only a value or magnitude, but vector there is magnitude, there are magnitude and direction. Yeah. Okay. Okay, the definition of vector is quantity that has both a magnitude and direction, and thus can be represented with a vector. Yeah. For example, this one is displacement vector. There are many several kinds of physics quantities like force, displacement, velocities, and then acceleration, yeah, torque. These are kind of vectors. Yeah. Okay. The important thing for vectors here is how to calculate, yeah, the resultant of the vector. Yeah, this one is vector sum or resultant of the vector. So for example, here is there is vector A and vector B, and then we can get the vector S. Yeah. Okay. Okay. Yeah. For example, if we have vector A, and then we have another vector B. Yeah. So we'll get the resultant here. For example, vector S or vector C. Yeah. The one is vector A, for example, and then vector B, and this one is A plus B. Yeah. Okay, the important thing of the vector is direction and then magnitude. Okay, if you can make the translation of the vector, yeah, if the magnitude and direction is the same, so the vector will be the same. For example, here, yeah, if we have vector A, like this, and then we can make the translation. Translation means the move this vector, yeah, to the right side, to the left side, or the other side. Yeah. If the magnitude and the direction of the vector is the same, so the vector will be the same. Yeah. So vector A, this is the same with this vector. Yeah. But if the direction will be reversed, so we can make the minus of the vector. Yeah. For example, this one. Okay, this one is the same magnitude but different direction. It means that minus A. Okay, minus A. It means the reverse of the first vector. Yeah. So minus A, it means that minus 1 times 2 vector A, right? So minus A, the direction will be different from the original vector. Okay. Okay. For example, for this case, yeah, I can move vector A, but in the same uh, schematic here, this one is vector B, and then this one is vector A, for example. Okay. Okay, this one is vector A, and then this one is vector B. So I can make the same resultant for this one. Yeah. I can take the line here. Yeah. And then this one is the resultant of the vector. Yeah. Okay. For example, this one is vector C. This vector C is equal to vector A plus vector B. So it means that this one and this one is the same. Yeah. Because vector A and vector B, I will change the magnitude and the direction. Yeah. This one is polygon, the polygon method, and this one is parallelogram method. Yeah. For adding the vector. Okay. So A and B here, yeah, you can set that this one is resultant of the vector. Yeah. Okay, any question? Okay, how to calculate the resultant of the vector? Maybe we can imagine or we can remember again about uh, cosinus, yeah, cosinus rule. Okay, for example, if I have the triangle here, A, B, and C, yeah, this one is the triangle. We can consider the cosinus rule, yeah. For example, this one is beta, alpha, and gamma. Okay, so alpha is the angle in front of the A, and then B is beta, C the angle in front of the C, yeah, gamma, this one. So for the cosinus rule, it states that if I want to, for example, take the value of A here, the value of A is A square, same or similar with B square plus C square minus 2B and C, yeah. And then this one is cos alpha, okay. This one is cos alpha. This one is this cosinus rule. And therefore the other one, if I want to take the B square is equal to A square plus C square minus 2A and C, 2A and times C, and then cosinus of beta, yeah, beta. And then C square, okay, also the same, yeah. This one is B square plus A square minus 2AB cos gamma, okay. This one is cosinus rule, okay. Yeah, we can remember again about this rule, okay. And then another rule is sinus rule, yeah, sinus rule. The sinus rule say that A divided to angle, yeah, the sinus of alpha is equal to B divided to sinus of beta, and then C divided to sinus of gamma, right? So this one divided to the in front of the angle, yeah. Okay, let's try to prove this theorem or this rule. Yeah. For example, we will take the special angle. Okay, for example, we take that this one is 37, and then this one is 53, right? And then this one is 90 degrees. Okay. If I want to take the X, Y, and then R, yeah. Okay. So for example, that X is 6 maybe, yeah. And then this one is 8, yeah. So we can get R, right? So by the using cosinus rule here, can get that R square is x squared plus y squared minus 2xy cos, then in front of the r is 90 degrees, okay? 90 degrees. Okay, and then r squared equal to 6 squared plus 8 squared minus 2, 6, and 8 cos 90. Yeah? So how much about cos 90? 0, right? 0. Yeah? So this one will be cancelled, okay? It will be 0. And then we can get the r squared is 36 plus 64. This is equal to 100, okay? And then r is the square root of 100. We can get 10. So the value of r is 10. Yeah. Okay. So this cosinus rule is proven. Yeah. So you can prove the cosinus rule here. And then you can try to another uh, schematic by using sinus rule or the other cosinus rule. Yeah. For example, if I want to take this one, 8, I can say that y here, yeah, y squared is x squared plus r squared minus 2xr. And then this one is cos 53, right? Yeah. So x squared is 36 plus 100, yeah, minus 2, 6, and then 10 cos 53. Cos 53 is 0.6, yeah. Yeah, 0.6. So this one is 136 minus, this one will be cancelled, yeah, 72. Yeah. So this one is 64, right? Okay, 64, yeah. This one is y squared, and then we'll get that y is square root of 64 is 8, yeah. Okay. Once again, the cosinus rule is proven, okay? So you can prove the cosinus rule by law, okay? Yeah, why do we need the cosinus rule here? Because for the vector resultant, we need to calculate by cosinus rule. Yeah. For example, in the polygon method or parallelogram method. Yeah. Okay, let's apply this cosinus rule to vector summation, yeah, or resultant of the vector. Okay, imagine if I have two vector here. For example, vector A and vector B. Yeah. Okay. So the way to write vector is there is the array in the top of the number or the symbol. Right? This one is the vector quantities. Okay, and then the resultant of this vector, yeah, we can add line here or dots. Yeah. Can add dots. This one is parallel to B and A. Yeah. And then take the value of the resultant. Yeah. Okay. Okay, for example, this one is the resultant of the vector. It means the A plus B. Yeah. A plus B. Oh, sorry. Okay. Yeah, if we have the angle of A and B here is theta, for example, the angle is theta, so we can move B to the right side. Yeah. So it will be like this. Yeah. This one is A, and then another one is B, and we can get the resultant here. Yeah. For example, this one is C. Yeah. A plus B. Okay. So because before this one is theta, yeah, so it's theta, right? It's the same angle. This one is one. So we'll get that this one, yeah, this one is 180 minus theta. Okay, 180 minus theta because the straight line is 180. Yeah. So we can calculate C by using the cosinus rule here. Okay. So by the cosinus rule, okay, the symbol for the magnitude of the vector, yeah, is like this. Yeah. It means that we have like the absolute value. It means the magnitude of the vector, yeah, is equal to A. This one is square, yeah, plus B square minus 2 A and B, yeah, cos. Nah, so the angle we use this one, right? Because this one the angle in front of C, yeah, 180 minus theta. Okay. Do you remember what is the value of 180 minus theta? Okay, so we can write here. Can write this one, yeah. C is equal to A square. This is the magnitude of A, yeah. And then B, and then minus 2 A and B cos 180 minus theta. It means that minus cos theta. Yeah. Why this one is minus cos theta? Because cosinus in the second quadrant, the value is negative. The second quadrant. Okay. Be you remember the quadrant, right? Yeah, I think it's one. The first quadrant, second, third, and then fourth plus. So because this one is 100 minus 8, 180 minus theta, this one is the second quadrant. The second quadrant is one. This one is theta is 180 minus theta. So the angle of the value of the angle is more than 90. So the value of cos here will be negative. Yeah. Minus cos theta. And then because there is minus and minus, will be plus. Yeah. This one is positive because minus times minus. So the value here is C is A plus B, yeah, plus 2 A and B. We can write cos theta here. Yeah. So we can derive the equation for resultant of the vector by using cosinus rule. Yeah. This one is cosinus rule. Okay.